If you recall, on Thursday, we're going to have practice test 2. Once again, we've only got 2 things to worry about practice test 2. This is on Thursday in the second half of class. So if you're trying to skip the maximum amount of class, just show up at 10 after 2, do the problems, and then you can leave. But if you feel uncomfortable doing that, just show up at 1 like normal and then hang out for an hour while we talk about new stuff. Do the test problems at 2, and then you can go. There are 2 things that you need to do. The first page is going to be the unit circle in degrees with 30, 45, and 60-degree reference angles in all 4 quadrants and the quadrant angles. It's going to look like this. And you're just going to have to fill in the stuffs what I filled in here. Just the angles 0, 30, 45, 60, 90 going all the way around the triangle and the coordinates. So really, I'm asking for just the cosine and the sine of each of those angles. Remember, the coordinates are cosine and sine. This combines what's positive where with some exact values. This is us learning the unit circle from 0 to 360, because it's not always going to be in degrees. And this week, we learn a new way to measure angle. I think for the sake of neatness, I am going to include the 1/2 lines. I'm going to include the horizontal and vertical places where we are at 1/2. So I'll include this circle. That's one of the things that you'll be given. You have to know that the lower ones close to the x-axis are the 30s, the taller ones are the 60s, and then you can cram the 45s in between. It seems like a lot to remember, but it's not really that much. It's 30, 45, and 60 in all 4 quadrants. And then it's combinations of 0, half, root 2 over 2, root 3 over 2, and 1, plus and minus versions of those all the way around. There's a lot of ways you can remember these values. You don't have to stop and memorize all these points. You want to look for patterns, find ways that you can remember these points going all the way around. This is your times table. It helps us have discussions later on to know how these patterns work. In particular, you want to notice x starts at starting at 0, cosine starts at 1, sine starts at 0. And then we go 1 down to root 3 over 2, root 2 over 2, 1/2 down to 0. And then it just goes down following the same pattern. So -1/2, negative root 2 over 2, negative root 3 over 2, -1. It's handy when you're trying to learn these values. If you want to use your calculating machine will not be spitting out exact values depending on the calculating machine you happen to be using. So if you happen to forget, put your calculator in degree mode and say which one is which. Just do sine of 30. Sine of 30 is 1/2. Cosine of 30 is 0.8660. And you have to recognize that's root 3 over 2. You've got to be able to recognize things like that if you're going to rely on your calculating machine. Any questions? Comments? That's one of the pages. It'll just be like that. The other page, you'll be given a trig value and a quadrant, and I'm going to ask you to find 2 other trig values. So if I give you the sine, I'm going to ask the sine of theta, I'll ask for the cosine of theta and the tangent of theta. And we're going to practice that today. So it'll be similar to these problems and similar to the problems that we're going to practice today. You can solve these problems on the second page by using your reciprocal ratio and Pythagorean identities. I will be printing those 3 categories of trig identities on the test. So up at the top, I'll have the reciprocal, the ratio, and the Pythagorean identities. 3 reciprocal identities, 2 ratio identities, and our 3 Pythagorean. So you don't have to memorize those. You will be able to use your calculator during the test because it's nice to have, but you're going to need to write exact values. So I was thinking about this and I want exact values. And so that's the thing that we're going to practice today. We're going to work on dealing with radicals today so that we're confident on Thursday in writing exact values. Any questions? Comments? How's everybody, okay? You still look super stoked, even though I announced practice test 2, but you knew that was coming. So everybody's still equally stoked. Actually, you should be more stoked at this point because we're close to the end of class. Or maybe it's like decreasing and then it increases when you reach halfway. I'm not sure. I don't know. I don't know what your personal graph is. There's a lot of stuff that we can do with radicals, but let's talk about specifically how radicals are going to show up for you in trig. So radicals are typically going to show up because we've used some Pythagorean identity. So they're going to typically show up. These are going to show up when we use a Pythagorean identity or the Pythagorean theorem, if we're thinking in terms of right triangles. So some of you are solving with identities. It's going to show up, your radicals are going to show up with identities or some theorem. You're going to use the Pythagorean theorem. I want to give you a few options for how to deal with problems if I send you a fraction. But suppose I send you a fraction, sine of theta is -2/3, and theta is in quadrant 3. First of all, you want to check to see if I was paying attention. Sine is negative in third quadrant, so we're good. I didn't give you a bad quadrant or a bad value. There's a few ways we can go about this. We can think in terms of identities, or we could think in terms of triangles. So if we want to do this in identities style, in identity style, if I have the sine and I want to find the cosine, I'm going to use cosine squared plus sine squared equals 1. So in identity style, I'm going to grab my Pythagorean identity, cosine squared theta plus sine squared theta is equal to 1. And I'm just going to replace what I know. Sine of theta is -2/3. So cosine squared theta plus sine squared theta, which is -2/3 squared, is equal to 1. At this point, we have fractions raised to powers, and so we look at that and say, ew, we don't like fractions, but deal with the fractions. It's easier than deal with like 2/3, which is 0.67 or 0.667 or 0.66667 or 0.6 repeated, because the 6's go on forever. So just deal with it, a 2 and a 3, then you have to worry about an infinite number of 6's. So when you have -2/3 squared, you could just square everything. Cosine squared, I spelled O wrong. Negative squared is positive, 2 squared is 4, 3 squared is 9. Just deal with it as a fraction. It's more efficient to just deal with it as a fraction. Now we need to subtract the 4/9 from both sides. We can read the 1 as 5/9. Sorry, 9/9. So when we subtract 4/9, we get to 5/9. I was thinking too far ahead. So cosine squared is 1 minus 4/9, which is 9/9 minus 4/9, which is 5/9. If we're like, all dudes still don't like fractions, if you do 1 minus 4/9 and hit the math button and say convert that to a fraction, it'll give you a fraction 5/9. Your calculator can do some fractions. So the fraction command is under the math button, which is funny because it's a calculator. They're all math buttons, but there it is. It's the first thing under the math menu. Just hit enter. Now we need to do square roots. We know that radicals are going to show up. Unless I pick very carefully what size of triangle we're doing and what ratios we're going to have, we expect radicals to show up. So the cosine squared is 5/9. So cosine by itself is plus or minus the square root of 5/9. The square root of 5, when we have the square root of a fraction, we can just apply the radical to the top and we can apply the radical to the bottom. Exponents distribute over products. Exponents distribute over products. Radicals are just exponents. Quotients are just products. So I can write plus or minus the square root of 5 over the square root of 9. And we know the square root of 9 is 3. See, we're doing radical practice here. So this is square root of 5 over the square root of 9. So plus or minus root 5 over 3. Exponents distribute over products. Then we just have to make sure we get the correct cosine. We're in the third quadrant. Cosine is negative in the third quadrant. So we'd say cosine of theta is negative root 5 over 3. Cosine is negative in the third quadrant. Now, this is a lot of writing. I don't expect you to write all this. That's crazy. There's too much of it. If you need to write all these things to arrive at root 5 over 3, then go ahead and practice writing all these things. Your goal should be to not write so much. Your goal in the math class is to not write so much math all the time. Any questions? We still need tangent. I'm always going to be asking for 2. Whichever one I give you, I'm going to ask for the other 2. Just the sine, cosine, and tangent. Not worry about secant and cosecant and cotangent at this point. So we need to find tangent, but now we have more information. Now I can use tangent is sine over cosine. Sine of theta is negative 2/3. Cosine of theta is negative root 5 over 3. And I can cancel out the over 3 parts. Multiply top and bottom by 3. And this is positive 2 over the square root of 5. This is going to be an acceptable answer. You can leave things not rationalized. I'm perfectly happy with that. Question? Yes. So this will be written at the top. At this point, since we have the signs included with the sine and cosine, I don't have to worry about tangent being positive in quadrant 3, although that's a good check. We expect tangent to be positive in quadrant 3, and it is positive in quadrant 3. So tangent of theta is 2 over the square root of 5. For the purposes of this practice test, you can leave your fractions, right? You can leave radicals in the denominator. That is okay on Thursday. If you don't like this, if you like all leech, I find that completely unacceptable. I was trained to not leave radicals in my denominator. Then you can rationalize your denominator. Multiply by root 2 over, or root 5 over 5. And you would say tangent of theta is 2 root 5 over 5. Rationalizing denominators is optional. You should decide now how you're going to leave things. If you're going to attempt to rationalize or not. You can decide now. Any questions? Is everybody okay? One thing that is useful is you do have calculators. So if you want to check that you rationalized it correctly, if you check 2 divided by the square root of 5 and compare that with 2 times the square root of 5 divided by 5, if they come out the same, you're probably right. At least you rationalized correctly. Is everybody okay? This was identity style. Not our only option. This is identity style. Triangle style. -2. Now it's important to remember that we are kind of going to be showing up with the same values. We're going to get the same values. That's okay. In triangle style, we're going to read the sine of theta is -2/3 as opposite over hypotenuse. We're going to read this as opposite over hypotenuse. And we're looking at it and we're like, oh, dude, that's negative. We can't have negatives in triangle. We do have negative coordinates. That's okay. So just remember, if you're going to do triangle style, hypotenuse is the positive one. Otherwise, we'll have to pay attention to the quadrants. So we are in quadrant 3, so I'm going to draw my triangle in the 3rd quadrant. I'm not going to draw the whole quadrant here. So I'm just going to draw a theta in the third quadrant. Here's my theta in quadrant 3. And then the triangle that I'm going to draw is going to have the reference angle for theta in the third quadrant. The way we read this is that we're looking at sine of theta is -2/3. We're going to read this as opposite over hypotenuse. So my hypotenuse is 3, and my opposite will be -2. Now we just need to find the adjacent with the Pythagorean theorem. So adjacent squared plus -2 squared is equal to hypotenuse squared. So the adjacent squared plus 4 is 9. So the adjacent squared is 5. So the adjacent side is plus or minus the square root of 5. Since we're in quadrant 3, I'm going to use negative square root of 5. So now if I want the cosine of theta, I do adjacent over hypotenuse. And if I want tangent of theta, I do opposite over adjacent. Same rules as before. You could leave it as 2 over root 5. It's okay to have a radical in the denominator. If you want to rationalize, you do the same thing. Root 5 over 5, root 5 over root 5. You feel like, I don't want any radicals in my denominator. You can't have radicals in your denominator, otherwise your radicals are like undermining things. Notice that there's a lot of similarity between this calculation and the previous calculation. The previous calculation just had, instead of a 2 squared, it was 2/3 squared. The previous problem divided by 9. That's all. This is the same thing divided by 9. Because the radius of my circle here was 3. The radius of my circle in the previous method was 1. You're not doing anything different. It's just showing up in a slightly different form. Question? Yes. Nope. That would require me say do this. And for things like tests, I don't say do that. I want to see where you're coming from. I want to see what kind of music you do. Any questions? Let's see what resonates, what sparkles with the group. Is everyone okay? The other way things might show up. Notice that in this example, we had sine of theta is -2/3. I just gave you a fraction. Sometimes it's weird. Sometimes we think it's weird. I don't know. Sometimes you don't think it's weird, and it's just like another problem. Who knows? So let's suppose that I'm going to keep the same thing. I'm going to say sine of theta, but I'm going to give a different value. Let's suppose that sine of theta was negative square root of 7 over. Actually, it needs to be less than 1. That'll do. For those of you watching at home, you're like, oh, dude, Leach, did you just have to look up what the square root of 7 was? I'm like, oh, shut up. Don't at me in the comments, because I turned comments off to avoid just that thing. It's weird when no one pays attention to your YouTube channel, you can almost get away with it. Almost get away with it. People don't come to your channel and leave like shitty comments. So your comment section isn't mean like a typical YouTube channel, but it is pornographic. Because the porn sites don't care if you've only got like 4 viewers. They're like, oh, I can post something in the comments. So that's why I just turned them all on. But now. So in this case, I've given you a radical. Not doing anything fancy. So when this gets squared, the square root of 7 squared just becomes 7. That's all. That's all I want to point out with this. So if we do identity style, cosine squared theta plus sine squared theta is equal to 1. The sine is negative root 7 over 5. What I want to point out with this example is that when you take the square root of 7 and square it, you just end up with 7. That's the whole idea behind what a square root is. Square root of 7 squared is just 7. 5 squared is 25. Notice that what we do on the other side is the same thing. When we subtract 7/25 from both sides, we're still just going to be subtracting the 7 from the 25. It's the same move with slightly different numbers. We just came at these numbers a different way. We're still going to subtract 1 minus 7 over 25. This is still a question of what's 25 minus 7, which is 18. All the same stuff is happening. So that's thing number 1 that I wanted with this example. The square root of 7 squared is just 7. But don't do that to both of the numbers. It's the square root of 7 over a regular 5. Square root of 7 squared is 7. Square root of 5 squared is 25. In this case, we would want to pull the negative square root because we're in quadrant 3. And it's the same thing. Cosine is negative in quadrant 3. This would be an acceptable answer on this problem. I would be super happy with this. If you knew what you needed to subtract, you needed to subtract the squares. And the square root of 18, you just left this square root of 18. We don't have to leave square root of 18 as square root of 18. You might find this offensive. Leaf, that's terrible. Square root of 18. We need to simplify that. The reason that we can simplify the square root of 18 is that 18 has a square factor. What's a square factor of 18? Is 4 a factor of 18? No. Are you saying no, or are you saying 9? No in German. Or are you saying 9? Oh, 9. 9 is a factor of 18, and 9 is a square. So I can split the square root of 18. We can simplify the square root of 18. Eighteen is 9 times 2. That shouldn't be a stumper. And the square root of 9 we can simplify because exponents distribute over products. So we can simplify the square root of 18 because 18 has a square factor. We can simplify the square root of 18 because 18 has a square, 9 as a factor. And then we could exponents distribute over products. So we could write cosine of theta. The simplified version of this would be cosine of theta is negative 3 square root of 2 over 5. Either way is fine. I'm happy with the square root of 18. If you want to simplify that to 3 square root of 2, make sure you use your calculator to see that you simplified that correctly. And don't forget the negative when you simplify. That's what happens all the time, and it's kind of sad. Any questions? Both are acceptable. If you do remember how to simplify your radicals, you can try simplifying your radicals, but make sure that they're coming out correct. I care more about getting at the square root of 18 part than simplifying it to 3 square roots of 2. Any questions? How's that about okay? The reason that I don't care about this that much, it's a useful thing to know, but the reason that I'm not concerned about this, if we want to know the square root of 18, we could just say, hey, calculator, what is the square root of 18? And it's like, 4.24 and a bunch of other stuff. I don't know if the calculator gets mad when like, oh, great, 4.24. And the calculator's like, oh, dude, look at all these extra digits that I have. And like, oh, no, I just care about those 3. The calculator's like, oh, come on, man. But the reason that because we have calculators, we don't really need to simplify radicals anymore. Because it used to be that we'd have to simplify the square root of 18. We wouldn't know that when we don't have a calculator. But we would know. You, as a math student, would just remember that the square root of 2 is 1.414. And you're like, oh, square root of 18 is 3 square roots of 2. So I'll just take the square root of 2. That I know. You just happen to remember that because you've come across it so much. You just remember that root 2 is 1.414, and you would multiply that by 3. Not on a calculator because you didn't have a calculator, as this is a long time ago when we were doing things on rocks. I'm just kidding. Slide rules made of rocks. Does anybody know what a slide rule is? I know what a slide rule is. I do not know how to use a slide rule. I don't know if that makes me not a real nerd. If you're going to know true Scotsman at me as far as my nerd cred goes, that's one place to go. Any questions? How's everybody okay? No, it's correct. There's a practice test on Thursday. So let's take a break, come back and have some practice for our practice test on Thursday.